Hey Glenn, check this baby out.
Yeah.
We have a taper here we're going to grind. It's really kind of cool. And this happens to be a quill for an ID grinder, which means it holds the ID wheel. We have to, in order to grind this, we have to lap the centers, as you can see here, which have been done. Now, why is that important? Because if there's a bump in here, or an imperfection, or a piece of dirt or grit, and you're using a center that's not a full center, and by the way, we will have to do that on this end. That's why we're going to use or show you this center. So it will act as a cam. It'll bump in, bump off, bump in, bump off. If you had a full center, it wouldn't really matter, because if the dirt's in there, the dirt's in there. As long as it doesn't move, it's going to be where it's at. Now what it would cause it to go not out around, but it wouldn't be concentric with the other end. So again, it's important that you keep the centers clean, free of any debris, and make sure that when they're lapped accurately. And if you do that, you're going to save yourself a lot of trouble from having scrap parts. So, but what this is all about today is we're going to grind this taper, which happens to be 25 thousandths per inch, as I recall. And the way to do that is probably, I can think of 4 ways. The best way, in my view, is the OD grinder. We'll put it on the OD grinder, we tip the table, and we grind this exactly to a dimension that we need, because it's important that you find the dimension you need up here, because obviously if you take too much off, this will fall into the socket and it'll be too far in. You don't take enough off, it'll stick out too much. So there's a dimension right in here that we need to hold. And we're not going to worry about that in the back, but I just need to mention it, that it's important that you understand that you have to hold a dimension in here. If you take too much off, you got a problem. Not enough, you got a problem. So how else could I grind it besides the OD grinder? Well, how about this? A tool post grinder on a lathe. Don't like that idea, but I could do it. So it's going to depend on any kind of equipment you have in the shop. Tool post grinder, in my view, is great for an emergency, but you put it on a lathe and you dress it and you get the grit all over the place, even if you put a towel in there. Let me show you what the tool post grinder looks like. We have a picture of one right here. And as you can see, it bolts on the tool post. That's why they call it a tool post grinder. Bolts on the tool post of the machine. Any degree of accuracy, in my view. I think it's pretty tough to do that. But there's another way I could do it, and that's on an ID grinder.
Well, did you just say ID?
ID grinder, that's right. We could do it. That's right, Jim. We could do it on an ID grinder. Would I do it there? In a pinch, if I had to. Not ideal, but I could do it on an ID grinder. The other way that I really like, and that's to put it in a spin fixture. The spin fixture bolts on a sine plate. The sine plate is tipped up. You take the whole assembly, put it on a surface grinder, and then you can grind it on a surface grinder. I like that a lot, and I like the OD grinder a lot. We're going to take you out back, and we're going to show you how we can do it on A, the OD grinder, and on B, on a surface grinder with a spin fixture. Let's go out back, I'll show you. So here we are back in the shop, and remember what we talked about? The first thing we want to do is clean off our chuck. Remember the little brush that I said we cut the bristles off? It's nice and stiff. It's great for getting rid of the grit from the grinding wheel. And of course we want to stone it. So we're going to take our little stone. You can feel it. If you use 2 fingers, you can feel the burrs on it. In this case, it's pretty good. I don't really feel anything. Now, we're going to put a parallel on here to give us a little room to get this way with the grinder. We already have set up the sine plate, and we put the master grind on it, our spin fixture. Glenn, can you get a shot of that? And it bolts right on here and here, and it registers against the side rail, so we know that it's square. Now, if we put this on, think about this, we're going to be grinding a taper. So we know that this particular taper is 25 thousandths per inch on one side. Remember, you're grinding two sides. You're grinding this side. That side is also being ground based on the center line. To explain it another way, think about the center line of the part, and we want 25 thousandths per inch from the center line to this top part. Obviously, it's going to be double because when we rotate it, we're grinding both sides. You got that right, Glenn?
Oh, yeah.
Does that make sense? All right.
Makes a lot of sense.
All right, so we're going to lift this up, set it over there. Hopefully, we've got enough room. We put the gauge blocks in there. And again, remember, when you're setting this up, you got to think about it, that you're only really grinding one side from the center line, not two, so don't make that mistake. It's easy to do. Also, keep in mind, when you're grinding a taper, if you don't have this perpendicular to the wheel, this way or this way, you're actually going to change the taper, right? If you're grinding a part this way, taper's going to change, so we don't want to do that. I've already dressed the wheel to save time, so we'll come in here and make sure we can clear it. I'm not positive we can clear the safety guard. But we'll take a look at that and see. It's going to be pretty tight. So, let me see if we can make an adjustment here. The problem is the clamp. See if we can move the clamp back just a little bit. Get the right wrench. The thread on the clamp is right in the way. Worst case is we may have to use a different set screw on here. That's for Brad. Boy, we're really tight. I always like to make my passes without the machine being on. That way you don't have to worry about having a major accident. I think we're right there. So, again, I want to make sure that I'm square on the wheel. Snug it down just a bit. Bring the wheel down fairly close. I'm pretty good with that. Turn on the spindle. Rotate the opposite direction of the wheel. That was pretty close, wasn't it?
Very.
You got that on the other camera, right?
Oh, yeah.
Beautiful.
Wow, look at there.
Almost cleaned up. I'm an advocate of one pass if you can make it work that way. Now we're going to walk it off. I love it. I love making sparks. Love being a tool maker. Always safety first. Almost there. About another ½ inch. Remember, you got to rotate the fixture opposite the direction of the wheel. Now, could you use coolant? Yes. Should you? It's always a good idea to use coolant. For the purpose of this demonstration, I chose not to do it. It makes a bit of a mess, but it's a damn good idea to do it. So as a young toolmaker, I loved working on the ID grinder, OD grinder, and surface grinder. ID always sounds like it's a bit of a challenge, but it's really not. And this taper, as I mentioned earlier, we can do it in a number of places. On a lathe, or in an ID grinder. Not ideal, but I could do it if I didn't have all the proper equipment. So we'll take a look at that and see what we've got. Well, I'm a little disappointed in that I didn't quite come all the way off, which means I'm going to have to put another parallel in there to stick the grinding fixture back towards me a little bit more. So stand by while we do that.
The left one is that's us.
All right, we take our finished cut. And you can see nice even sparks. It looks like we're taking a lot of stock, but we're not. Right at the very end here, we're going to take a little more than we needed to. There we go. I think we got it, so I'm going to turn the wheel off just to be safe. We'll leave the fixture on the machine, but we'll remove the part. Looks pretty good.
Very pretty.
All right, so how do we know that it's accurate? Well, we can put a little Prussian blue on it, as we used to call it when I was a kid, and we just put a little dab on there and we'll put it in the mating part and see how it fits. If we get the blue nice and even, we know that it's going to fit right. If not, then we've got to readjust our angle and do it again. Let's give it a try. And by the way, that's about all it takes. You don't need much. So I'm going to put it in the mating part. I don't know if you can get that because we're way over here, but I'll put it in the mating part and bring it back and show it to you. Well, here's what we have. What does that tell you? It's a little high here and a little low there. But it's not bad. It's probably tolerable. For the purposes of this machine, this is going on an ID grinder. It's a quill for it. I'm okay with it. It's going to be fine. If this were a precision gauge, this wouldn't pass muster. I'd have to do this over again. What I would do would probably be to drop the sine plate down just a hair. Remember, the sine plate's correct. The dimensions that we used are correct. The spindle that this slipped into is what's off. That's what's wrong. But if you want to mate it to the part, then it doesn't matter what the sine plate does. What matters is what is the mating part. But in this case, again, it's fine. So another way to grind this, and we're going to show you, is on the OD grinder. So we're going to take you over there. We're going to do another part just like this on the OD grinder. So let's take a look over there. So here we are now at the OD grinder. And one of the things I can't stress is the importance of keeping the bed clean where you slide the tailstock back and forth. When you dress the wheel, the grit gets all over the place. And when the grit gets all over the place, then it gets underneath the tailstock. That wears it out. That causes a lot of complications that you don't need. So what I like to do is before I move it, I want to make sure that I wipe the back side and absolutely wipe the front side because I know I'm going to go forward in this case. And now that I've done that, because I did it before you were on camera, Glenn, now I can move my tailstock in. And we can set it up so we can make sure we can get our part in and out. I think I can move it just a bit more. There we go, I like that. Now, we're going to use this as our master. There's already a taper ground on this, and this is the taper that we want. So I have a dial indicator on here. I'm going to sweep this back and forth until it registers 0. So I'm going to tip the table in this direction to make sure that I get the taper correct. So stand by while I do that. Pretty good. It's within a couple tenths.
Yeah, it is.
All right, so we've got it set up based on our master. So now we're going to grind the taper on the one we just got back from heat treat. All right, so we've got our master all set. We're going to take the part that we're going to grind. We're going to grind this taper on here, and we're just about ready to roll. That feels pretty good. Put the guards back on. I don't like getting splashed all over the place. There's no point in that. So we're getting close. Now I dressed the wheel, so we should have a pretty good finish on it. Come right up against the shoulder or close to it. Get our coolant ready to go. I like to put the coolant on and watch it wipe it off. That tells me that I'm getting close. I'm hitting in the corner right now. That's a good sign. And it should clean up pretty even. Well, I know you're there somewhere. Where are you? There you are. I knew you were there. I like it. It's running out a little bit, but that's, you know, normal from heat treat. So let that settle down just a bit. Now, Glenn, you see all those sparks? That looks like a lot, right?
Yeah.
That's not much of anything. That's probably 3/4 thousandths of side. That's all we're taking off. But it looks like we're getting ready to do some arc welding.
Yeah.
So we'll come back and make one more pass to get a super good finish. And then we're pretty much done as long as our size is good. So we'll give that about another 1/2 thousandths. I like to wiggle it just a little bit to let it settle in. I mean, that's nothing. That's probably 20 millionths you see there. I like to count the sparks coming off the wheel. And I would say that this baby's going to come out just the way we want it to. So I'm pretty excited about it. I think we're going to be very good. Again, I always like to pull when you're coming off the wheel. I like to pull back. Believe it or not, that's only a few tenths, but it makes a difference. You don't get a trail on it when it's coming off the wheel. So I think we're pretty good here. Oh yeah, look at that.
It's real pretty.
That's a beauty, isn't it? Okay, so what we're going to do now is we're going to put a little bluing on there, and we're going to try to seat it in the mating part. Again, we're going to seat this to the female part of this ID grinder. Put it in a couple times, see how it feels. Why is that important? So we don't get any shimmy in there, we don't get any vibration. This thing's running at a high speed, it's liable to whip around. So we want to get it as close as we possibly can. And that's really not so bad. It's hitting both sides. On this side, it's not quite as much, but the thread could be a little bit out of round and pulling at one side or another. So I think for my money, that's pretty good. So I'd buy that. So there we go. So that's how we use the Dicom blue, and that's how we try to seat it to the mating part. So that's another way to grind a taper. So thanks for watching.